Hello, it's Daniel from TechMind Factory, and in this video we are going to talk about secure cloud deployments with GitHub Actions. So let's start. In this video specifically, we are going to talk about deployments from GitHub using GitHub Actions to the Microsoft Azure cloud. But before we start, let me show you this, I think, very famous sentence. So, oh no, the secret expired. So until now, probably you are very familiar with this approach. Until now, when we wanted to deploy anything to the Microsoft Azure cloud from GitHub, we had to register new application in the Azure Active Directory, so create service principal. And once we did it, we got client ID and client secret, and those values can be stored securely on the GitHub side under secret stub. And which is fine, of course. So we can still securely store those parameters, and then it means that we can securely communicate with the Microsoft Azure cloud. And once we are authenticated, we can deploy our new packages to different resources in the Microsoft Azure cloud. And this is perfect, but there is the problem because secrets expire after some time. And we have to rotate them, we have to recreate them, and it can be painful. So it means that once secret expired, we cannot deploy anything to the Azure cloud anymore. And saying that, there is another new solution which is in the preview at the moment of recording this video. So Workload Identity Federation. So using Workload Identity Federation allows you to access Azure Active Directory protected resources without needing to manage secrets for supported scenarios like GitHub Actions, Google Cloud, workloads running on the Kubernetes, workloads running in the compute platforms outside of the Microsoft Azure cloud. And of course, in this video, we are going to talk about Workload Identity Federation using GitHub Actions with GitHub Actions, but in the end, you have to remember and know that with this approach, you can eliminate using secrets. So this problem about expired secrets will not exist anymore in the future once you use this approach. So just to clarify, you use Workload Identity Federation to configure an Azure Active Directory app registration to trust tokens from an external identity provider, such as GitHub in this case. So we want to trust those tokens that are generated by GitHub. Once that trust relationship is created, your software workload can exchange trusted tokens from the external identity provider for access tokens from Microsoft Identity Platform, so from the tokens from the Azure Active Directory. So let's talk about this workload and this flow here to better understand what's happening underneath. So we have external workload. So in this case, this is GitHub Action workflow in this case. There is external identity provider, which is GitHub. And of course, there is Azure Active Directory connected with our Azure subscription. And of course, there are some other components here which we will describe in a minute. So first of all, what is happening when we set up this approach, our external workload, so in this case, GitHub Action requests a token from external identity provider, which is GitHub in this case. So the GitHub Action workload requests the token from GitHub. And GitHub issues this token to the workload, so to the GitHub Action. And then GitHub Action sends this external token to the Azure Active Directory, which is, of course, federated because we register this application and we configure everything as it should be, and we will describe it in the demo in a minute. But GitHub workflow, so GitHub Action, sends this token to the Azure Active Directory, and Azure Active Directory checks the trust relationship, validates this external token provided from GitHub using OpenID Connect Issuer URL on external identity provider. So in this case, using OpenID Connect Issuer URL from GitHub. And once Azure Active Directory verifies this token, and the token is verified, then Azure Active Directory issues an access token to the GitHub Action workload. So in this case, once the access token is obtained, then our GitHub Action can access resources protected by Azure Active Directory. So resources under our subscription connected to this specific Azure Active Directory tenant. So in this case, in the end, we can, for instance, deploy our application to the Azure web app. So as you can see, it's very sufficient and it's very elegant, because in this case, we can just exchange those tokens, and in the end, we can securely deploy our packages to the Microsoft Azure cloud. Okay, so just to clarify, there are two different ways of authentication with Azure from GitHub Action workflow. So the first one is logging using Azure Service Principal with a secret. So this is this standard and approach used until now. So we have client ID, tenant ID, client secret. We store those values under secrets on GitHub, and then we have to deal with this secret expiration. And there is this new approach, so login using OpenID Connect based federation identity credentials without storing secrets. So in this case, we don't have to deal with secrets anymore. So in this case, of course, we use GitHub Action for Azure login. So first of all, we have to obtain the access token from the Azure Active Directory in the GitHub Action workflow to securely communicate with Azure Cloud and make the deployment. Okay, great. So what are the benefits of using OpenID Connect approach here? So first of all, there is no long-lived cloud secrets in this case. So you won't need to add any long-lived cloud credentials at GitHub secrets and worry about token expiry and rotating them. So in this case, we don't have to worry about the secrets. The second thing is that authentication and authorization management is, I would say, easier, and we have more granular control over which workloads can access cloud resources by using our cloud provider authentication and authorization tools. So in this case, we can manage it using Azure Active Directory. And with OpenID Connect, our cloud provider, so in this case Azure, issues a short-lived access token that is only valid for our single workflow job, and then automatically expires. So it means that this access token generated from Azure Active Directory is only for our specific GitHub Action workflow. Okay, so it's time to see it in action. So let's jump in and see how to configure this whole thing. For the demo purpose, I will use one of my open source projects available on GitHub called Cloud Pharmacy. The link to this source code repository is provided in this video description. If you look at the solution architecture, you will notice that I develop multiple APIs and web apps. So now I want to securely deploy packages with my applications to the Azure Cloud resources. So let's see how to do it. To use Workload Identity Federation, we have to first register application in the Azure Active Directory connected with our Azure subscription. So to do it, I encourage you to check one of the links I provided in this video description called Configure an App to Trust a GitHub Repo, which is currently at the moment of recording this video in preview. So under this link, you will notice what has to be done when it comes to application configuration in the Azure Active Directory. So now let me show you the application I registered. I followed the steps from the Workload Identity Federation documentation, so the link is provided in the video description, and I created new application in my Azure AD tenant, which is obviously connected with my Azure subscription where I have my different Azure resources. And under Overview tab, I can copy application client ID and directory tenant ID. I will use those values on the GitHub side. I will have to put those values under secrets. But this is not enough. Under credentials and certificates and secrets tab, I have to switch to federated credentials, and accordingly to the documentation, we have to add new credential. So I've already done it. So as you can see, here is my credential. So from the federated credential scenario list, I selected GitHub Actions deploying Azure resources. And under Connect Your GitHub Account section, I provided details about my GitHub account, my repository, and some other important parameters. So under organization, I provided the name of my organization, of my account on GitHub. Under repository, I provided the name of the repository. And for the entity type, I selected branch. So I want to deploy Azure resources once there is a GitHub action triggered from the main branch. So this is what I provided under based on selection. And here is important information in the documentation. The organization, repository, and entity type values must exactly match the configuration on GitHub workflow configuration. Otherwise, Microsoft Identity Platform will look at the incoming external token and reject the exchange for an access token. You won't get an error, the exchange fails without error. So it's very important to carefully fill out those parameters there. And of course, you can optionally provide description. So I provided this basic description that this credential enables automatic deployments with GitHub Actions. Here is the Cloud Pharmacy project available on my GitHub. The link is provided in this video description. And now to successfully complete this configuration for the Workflow Identity Federation, under Settings tab in my repository, I have to select Secrets and then Actions. And this is the place on GitHub where I can securely store the secrets and values that will be used by GitHub Actions. So in this case, I need to provide three secrets. Azure Client ID, which is the client ID of my application, which I registered in the Azure AD tenant. Azure Subscription ID, so the ID of my Azure subscription where my resources are deployed, like Azure Web Apps. And I have to also provide the Azure Tenant ID value here, so the ID of my Azure Active Directory tenant. And the client ID and tenant ID values can be found under Overview tab for our registered application in the Azure Active Directory tenant. So once we provide those values here, then we can securely access those parameters in the GitHub Action workflow. And please note that here we don't have to use any secrets anymore, client secret to configure this secure connection between GitHub and Azure Cloud. So now let's switch to the Code tab, and under Workflows folder, you will find that there are multiple workflows, but let's focus on one of them. So build and push Docker images. So this workflow is responsible for building and pushing Docker images with my APIs for Cloud Pharmacy to the Azure Container Registry. But of course, to push any Docker image to the Azure Container Registry, first of all, I have to authenticate. So in this case, I have to obtain the access token to securely deploy and push my Docker images to the Azure Container Registry. So here, let me enlarge this fragment. So here is where Workflow Identity Federation comes to play. So as you can see, first of all, of course, I have to check out the code. So I have to get the code from the source code repository. And then there is this next step called AZ-CLI login. So this is the place where I use those 3 secrets that I filled out just a minute before. So the client ID, so the ID of my application in the Azure Active Directory, the tenant ID, so the ID of my Azure Active Directory tenant, and the subscription ID of the subscription where I have my Azure resources deployed. So I need only this small step here. And also under permissions, I have to add ID token right to successfully obtain the token that can be exchanged for the access token in the Active Directory. So once I add those fragments here, I will successfully obtain the access token, and then I can build and push Docker images to Azure Container Registry. So here, as you can see, I can use ACR build. I can provide the name of my image, and I can successfully build and push those Docker images to my Azure Container Registry. And as you can see, again, no client secret can be found here. So now, if we get back to the Actions tab at the top of my repository, this is the place where we can see the execution history of all of our workflows on GitHub Actions. So I will select Build and Push Docker Images workflow, and I will select the latest execution. And in the history, in the steps, we can see that one of the steps after code checkout is AZ-CLI login. So this is the place where we can see that before we build and push Docker images to Azure Container Registry, we have to obtain the access token from the Azure AD. So this step will first of all call the Azure AD, exchange the ID token that was provided from GitHub. Azure AD will verify whether the workflow identity federation is configured properly, and then Azure AD will return the access token, and then this specific GitHub action workflow can then call Azure Cloud and securely deploy resources. So in this case, we can securely push Docker images to the Azure Container Registry. And that's it, basically. As you can see, we can still do it securely, but without using any client secrets. Thank you so much for watching this video. I hope you found it interesting and helpful. If so, please subscribe, because this will be the sign for me to produce more videos. See you in the next video.